This is Chapter 8, Univariate Data Analysis, Section D, Continuous Data. So we need to recall what continuous data is, and remember this is from Section B, and this is what I was talking about with there being lots of terminology that you need to memorize. So a continuous numerical variable can theoretically take any value on part of the number line. So it can be decimals and fractions and anything in between those whole numbers. And it's a variable that is often measured. So if we think about those examples that we looked at, well, the height of grade 9 students or the height of grade 10 students, and this variable can be anywhere between 100 centimeters and 200 centimeters. Well, that could be, 105.6 centimeters or 145 centimeters. So those numbers or data points can be anywhere in between there. The other example here is the speed of cars on a stretch of highway. So this could be a car traveling from anywhere between 0 kilometers per hour to 150 kilometers per hour. It's unlikely anyone's going 0 kilometers per hour because that would be very dangerous. So let's pretend our range could be between 50 and 150 kilometers an hour. But what we see is that the data can be anywhere between that, and it can't be counted because it's been measured. So let's look at now how continuous data is displayed, and you'll notice that it looks similar to discrete data in some ways, but it is different. So one thing that we need to recognize is that we use frequency histograms rather than column graphs. And the biggest difference that we'll notice is that these columns are joined together. So you'll see here it says no gaps. And that's to show how the continuous nature of the data. Rather than in a column graph, if you look down to the bottom left hand of the page, a column graph, there are spaces, and that represents discrete data. But when it is all merged together, it would be a continuous data set. Okay. The modal class, which sounds similar to mode, is the class of values that appears the most often, and it's usually very easy to identify on a histogram. Now, although they are slightly different graphs, they have very similar features. So we think about our vertical axis and our horizontal axis. Well, our vertical axis will have our frequency, and our horizontal will have a range of scores on it. So vertical, remember, is our y, and horizontal is our x. Now, column widths are equal, and the height varies according to the frequency. Okay. Histograms have no gaps between them, and that is because the data is continuous. So this graph is our big game changer for continuous data, and it'd be good for you to understand how to create one. So we're going to do an example on our next page. Okay, so here we have an example, and it says the weights of parcels sent on a given day from a post office were in kilograms, and it lists a huge set of numbers, and it says organize the data using a frequency table and then graph the data. The first thing that we need to recognize is that this is a set of continuous data, and that is because the weight can be anything between 0.1 kilograms, and I say that because it wouldn't be a part of this if it didn't weigh anything. And our highest value, if we scroll through, seems to be, let me see, we have 5.2. So we could say up to 6 kilograms, okay? Because that would be the highest possible based off of this data. Or not possible, but that would be the highest rounded up after our 5.2. So before I even look to making my frequency table with my class interviews, what I probably would do would be to organize this from least to greatest. And that's tedious sometimes, but it is really helpful. So if we look at this data, let me see, our smallest looks like 1.3. Okay, so we have 1.3, and then I see 1.6, and we'll just cross them out as we get there. Any other in the ones? Scrolling through, no, so let's go to twos. We have 2.2 and 2.5, 2.5, we have 2.8, and And then we have 2.9 and 2.9. Okay, now we'll move on to threes. So we have 3.1, 3, ooh, that was messy. 3.4, 3.7. Oh, there was a 3.2 in there that I missed. And I gotta go back. So let's erase some of these. Erase that, we'll erase that. So we had a 3.2, which is there. And then there's two 3.4s. Get those out of there. 3.5. Now 3.7, which I had already crossed off. Now we'll go into the fours. So we have 4.0, 4.6, 4.9, and 5.2. And I believe that is everything. So there we go. There's my data, and it's ordered. So I need to make a frequency table, and we talked about these class intervals. So we're going to have our weight on one side, and then we will have our frequency. So we need to think about what would be a good class interval. Well, let's see. We could break it into ones, and that would probably be the most appropriate. And then we would have how many? 1, 2, 3, 4, 5. We'd have 5 class intervals. So our first one would be between 1 and we'll say less than 2, because we are dealing with decimals here rather than exact whole numbers. So we need to clarify. So 1 to less than 2, and there are 2 of those. And then we will do 2 to less than 3, and there are 1, 2, 3, 4, 4 of those. 1, 2, 3, 4, sorry, 5 of those. Okay. And then we'll do 3 to less than 4, and there are 1, 2, 3, 4, 5, 6 of those. And then we will do 4 to less than 5, and there are 1, 2, 3 of those. And then if we did 5 to less than 6, there's just 1. So if we look at our data, the most frequent one would be between the 3 to 4 kilogram. Okay. That's where our modal class would be. The last thing it asks us to do is to create a frequency histogram. Now, it would be helpful for you at home to do this on a sheet of graph paper, or just make sure that you're using a ruler to create it, because we want it to be neat when we graph things. So on our x-axis, and it's good to label, so we have our x and y. On our x-axis, we will have our weight, which is in kilograms, and on our y-axis, we have our frequency. And we don't need to write, we could go by ones, we could go up by twos. It's kind of up to us. So if I look at my data, I have 1, 2, 3, 5, 6. I might choose to go up by twos, 2, 4, 6. And we'll make sure we represent our 0 there. And then for our weight, we'll just use our 1, 2, 3, 4, 5, and 6. So we have 1, 2, 3, 4, 5, and 6. And it's important that these are equally spaced. And I recognize that they aren't currently equally spaced on here. But again, please ensure that you're doing this on graph paper or using a ruler. So for packages that weigh between 1 and 2 kilograms, we saw our frequency was 2 for that. And then for packages between 2 and 3, we saw that our frequency was actually 5, so we shoot up. And then between 3 and 4, that's where we hit our 6. And between 4 and 5, we go down to 3, so that'd be about there. And between 5 and 6, there was just the 1, so something about that. Now, again, this is very, very rough, but I just want you to have a good understanding of how to do this frequency histogram. Now, remember that we have no spaces because it is representing continuous data. And other than that, I think it looks okay.